As we were discussing last video, we now know that atoms are combined in whole number ratios. And what those whole number ratios really are called now is formulas. So formulas are relationships between different kinds of atoms to show you how compounds are made. The easiest version of a formula, I think, is a molecular formula. And that simply says there's exactly this number of each atom. And when you have subscripts that are like this 2, what that says is that there's 2 hydrogen. So it refers to the number or the element that precedes it. Since oxygen does not have a number, it's an assumed 1, which means that water, or H2O, has 2 hydrogen and 1 oxygen. If there is no number, assume that that's 1, okay? If you have some formula like BH3, what this means is that there's 1 boron and 3 hydrogen. Now, there's also a type of formula called the empirical formula. This is kind of like the lowest common denominator. And so if you have a formula that would be the molecular formula of sugar, or glucose right there, it would be C6H12O6. But if you reduce this down to where a carbon would only represent 1 carbon, its empirical formula would simply be CH2O. So in other words, we divided each of these numbers by 6 in order to get this empirical formula. Empirical formulas can kind of be misleading, but there's times that they're quite useful when it comes to math. Next, we have a structural formula. As an organic person, I really enjoy structural formulas a lot. And this shows how atoms are connected through bonds that we represent as lines. So the structural formula for formaldehyde looks like, as you see right here. Both its molecular and empirical formula is simply COH2. And the reason why those two are the same is simply because it cannot be reduced further, right? We can't divide everything by 2 and still end up with a whole number for each of our atoms. You should realize that isomers are things that can also exist, and these are different connections of atoms with the same molecular formula. Okay, so now that we've talked about all of these elements and how they're going to combine to make these formulas, we really need to get into talking about the periodic table. Now guys, this man named Mendeleev, he was amazing. He grouped elements together just based on how they reacted. And the next thing you know, he put them together in patterns, and that's where we got our periodic table. So here's some things that you should be able to identify, and I'm going to go and show you these things in future slides here. But the difference between metals, nonmetals, and metalloids should be something you can identify. What main group elements, transition metals, lanthanide and actinide series are, and then the difference between groups and periods. And the big thing is you need to be able to identify these guys as well. Okay. So my favorite website is ptable.com. And this has a lot of really cool things on it that you can use, just looking at this periodic table. First of all, you see that metals, I can't actually choose that. If you click on metals versus nonmetals, you'll see them light up. Unfortunately, it looks like, maybe let me try this version. Metals, if I click on metals, it does tell you what those are, but you should see those light up in yours. Versus a non-metal, you can look at what those look like. Metalloids will also show up and highlight in a way that I simply can't do on here, and my apologies. But this periodic table will also give you the elemental information that you need for each of these elements. So say that you're looking at fluorine. you can tell what the atomic number is at the top, and you can tell what the atomic mass is on average at the bottom. And each of these element names will also give you what it represents, right? So F is standing for fluorine. B stands for boron. You should know what these are up to about number 35, because that is probably something that you will run into in the future, okay? So let's talk about the different parts of the periodic table. Notice that when we're talking about metalloids, see how this color green is right here? We're talking about the group that goes this way. And metalloids are kind of like they sound like. They're kind of like metals and kind of not. Silicon's part of this. And that's the reason why you can use silicon as a semiconductor. The things that are to the right of that stair step, so all of these guys, are non-metals. So this is a non-metal, okay? And finally, that means that all of these, everything else over there, and all the stuff down here, all those guys are metals, okay? So I didn't put it in there, but this part right there is metalloids. So you should know, here I'll put metalloids that way. You should know sort of the difference between those three. I think it's fascinating that there's so many metals that we have on our periodic table, but we don't walk around clanking like a bunch of metal. Well, the reason why is because those metals change through reactions, okay? Okay, so do you see how this starts with lanthanum and this starts with actinum? That's the reason why those are called lanthanide and actinide series. Okay? Blank periodic table here, and you might see something like this. I can basically, I'm okay with you being able to identify that there's a stair step of some sort here, and that's where metalloids are. And the things that are over here are non-metals. And then everything else is a metal, okay? But you should know that in general, that that's what's happening. Here again. Okay. Now let's talk about what main group elements means. It's simply that we kind of see how there's this stair step that comes out here. You see how there's this dividing line here? Well, what we consider to be main group elements, I'm going to color in blue. Oh, I think I am at least. Here we go. So this side and what we have over here on this side are main group elements. In green, I'm going to show you what the transition elements look like. So transition elements are things that are here that are in the middle of the main groups. So it transitions from one side to the next. Then we have what are known as lanthanide and actinide series. So I'll do this one in red. The lanthanides are on top. And let's see, we've got yellow left, so I'll do the actinoids in yellow. But let me show you an easier way to look at that. Let me go back a couple. So the difference between a group and a period is simply the direction of what we're talking about here. So groups go down. So these are all groups, things that I'm pointing downwards. And sometimes you'll see this as 1, 2, and sometimes you'll see this as 3, or it could be in Roman numerals, either one. And other times they call this 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and this becomes 13. So don't get confused. Both of those are still referring to the same thing. 14, 15, 16, 17, and 18. So those would be all of our groups. Periods, on the other hand, just mean that you're talking about the things that go from left to right. What we found is that groups have much more reactivity similarities than periods do. And so most of the time we refer to groups as being the things that are most important. So certain groups have common names. This would be our alkali metals. Okay. The next group, in other words, all the way down here, this next group is referred to as alkaline earth metals. Okay, I'm going to skip all the way to the very end. These are referred to as noble gases. They're very noble. We'll talk about that and what that means later. And these guys are referred to as halogens. And those are the four groups that we refer to the most. But you may hear also that this group is referred to as chalcogens. Okay, and those are certainly things that you need to know moving forward. Thank you very much, and I hope you're having a great day.